Lesson 4.6 is fitting data to a line. A lot of statisticians do this to make predictions about future data. And you start off with a scatter plot. So a scatter plot is a graph that's used to determine whether there's a relationship between paired data. Scatter plots can show trends in data. So for example, this one looks like as the x increases, the y increases. So we say that this has a positive correlation. We're looking at the scatter plot, but it looks like a line might fit nicely between all those scattered points. This one is said to have a negative correlation because as the x's increase, the y's decrease. And here, this one's sort of scattered about like a snowstorm. So x and y have no apparent relationship, sort of like your eye color and your shoe size. There really shouldn't be a relationship between the two of those. And we say that in that instance, there's relatively no correlation. Here, they're giving you an example of two scatter plots and two sets of data. First, we have the independent variable, the hours of studying, and the dependent variables, the test scores. And this looks like there's a positive relationship here. And it looks like we could quite nicely put a line right through it. Positive relationship. So we would say it's a positive relationship or positive correlation. And as hours of study increase, test scores increase. Whoa. And this next one, it looks like there's a negative correlation. And this one is as the hours of television watched increase. I'm just going to put TV. The test scores decrease. Whoops, not dest. So here we would say this one has a negative correlation. Okay, using the scatter plots from this example, predict a reasonable test score for 4.5 hours of studying and 4.5 hours of watching television. So here's 5 hours, so 4.5 is right around here, if I can get it to go up straight. And it looks like you're going to score about a 70. And 4.5 hours of watching TV, oh, looks like maybe you're going to score 78. So in this case, it looks like you benefit from watching TV as opposed to studying. However, if you look at the trend, the more hours you study, the better your test score. But the more hours you watch TV, the worse your test score. If you look at 8 hours, for example. So we do have to reach a certain point. What we're going to do now is we're going to take a set of data and we're going to fit a line. It's called line of fit. Sometimes it's called line of best fit. And the first thing you do is make a scatter plot. And then you look at the data and see, well, really, could it be modeled by a line? Does it look like it has a positive or negative correlation? Then we draw that line of best fit. And we should try to draw it so that there's approximately as many points above the line as there are below the line. And then finally, you pick 2 points that are on the line. They don't have to be data pairs from your original set of data, but they do have to be on this line of fit. And then once you have the 2 points, you can go ahead and come up with the equation of the line. So let's go ahead and do that. So I have the data points negative 2, 4, negative 1, 2, 0, 1, 1, negative 2, 2, negative 1, and 3, negative 2. And this does look like it has a negative correlation. So as the x's are increasing, the y's are decreasing. And it looks pretty linear. So if I draw this point or this line right here, let's see. Well, I have, this is not terrible. I have 2 points sort of above. This one's touching the line. So technically I have 1 point above and 1 point below, and the other ones are touching the line. What I want to do now is I want to go ahead and pick off 2 points from the line. Well, this one looks pretty good on the line. And then another one that's on the line, to me, looks like this point right here. So those 2 points are on the line. Now this second point here is not part of my data, but it is on the line, so I'm good to go. So I have the point 0, 1 and the point 1, 0. Now I'm going to find the equation of the line. Well, lucky me, my y-intercept is right here, 0, 1. It happened to be part of my line, and it's on the data. My slope, I could just do a rise and a run, 1 over -1. So my slope is -1. If you want to work it out, I would have 1 minus 0 and 0 minus 1. So 1 over -1. Any way you look at it, it's still -1. So the equation of this line that I drew is y equals -1x minus 1. So it's got a negative slope. We have the negative, oh, look what I did. +1, sorry. Positive y-intercept, it's a +1. See, it's a good thing that I went back and looked at that. So this was the slope, the y-intercept was a +1. Let's try another set of data. We have -4, 7, -3, 5, -2, 6, -2, -3, -2, I guess +3, -1, 4, 0, 2, and 1, 1. Now I know that these points altogether are not a function. Remember, a function, every x has to have exactly 1 y. Well, if I input a -2, I get 2 outputs. So that's why together this is not making a function, but it does certainly look like we could draw a line of best fit. And again, it's looking like it's negative. So if I draw it right here, I have 2 above, 2 below, everything else is at least touching. So yay for that. And again, here I'm going to choose this point, and I'll choose this point right here. So the 2 points that I've chosen that are on the line are 0, 2, and -3, 6. So again, I lucked out. My y-intercept is right there. And then my slope, I'll go 2 minus 6, 0 plus 3 to get a -4/3 for my slope. So my equation is y equals -4/3 x plus, I got it right this time, 2. And you can see that the slope does look like it's -4/3. If I go up 1, 2, 3, 4, 1, 2, 3, it works. And then my y-intercept is 2. Okay, here we have a thermostat. This is showing the setting in units called gas marks, and this is a British gas oven, and the corresponding temperature is in degrees Celsius. So we're going to go ahead and make this scatter plot. So at 2 we get 150, and if the gas mark is 3, it's 160. 4 is 180. 5 is 190. 6 is 200. 7 is 220. And 8 is 230. So right around in here. What's the correlation? Well, it looks like as the gas mark increases, so it's positive. Correlation. And I'll write it down here, as the gas mark increases, the temperature increases. set to a gas mark of 10, heats to a temperature of 260. Does this fit the trend that's shown by our scatter plot? Well, what I'm going to do is extend a line right through here and see if it would actually fit the trend. So here's 9, 10 would be right around here. If I followed it up, whoa, it does look like it would fit the trend. So yes, and I will just point over to my graph because that's an explanation enough. And again, as the gas mark increases, the temperature increases, and we've increased it to 10, and the temperature did go up. All right, here is your assignment. If you want to start it early, you're welcome to. Page 267 to 270, 1 through 11, 13, 14, 16 through 18, and 20.